Hi everyone, we are back with a new episode of APIM HotRod, and today I'm here with Aidan. Aidan, how are you doing?
Good. How are you, Massimo?
I'm very well, thank you. So the topic of today is infrastructure. So in this year season, we are just walking around different topics. So from solution architecture, today is infrastructure. We'll talk about containers, AI, etc., etc. We are having a sort of journey of the Azure architects from different dimensions. So today it's everything about infrastructure. So as usual, we have the wonderful maps of Stefan. Today, Stefan cannot be in this call, so he will be back from the next episode. So no worries, everything is good at his side. Today we were saying it's about infrastructure. Infrastructure is a huge topic in cloud, and that can be, very broad from the governance side, the security side, high availability, disaster recovery, and also if we look at networking per se, it's a single map. It's a single huge map. A lot of topics to learn and to master. So Aidan is a huge expert in infra and networking, and me, I'm coming from more the application side of it. So my first question for you, Aidan, is like, yeah, how can developers or people that are coming from application have the agility to work on this such a complex network scenario? And on the other side, IT, how the need for security, the need for compliance, the need to have everything under control. How do you see this interaction these days?
The interaction is traditionally fiery. So a little bit about my history. When I went to college, back when the dinosaurs were still roaming the land, I did COBOL, I did Pascal, I did C, I did C++. And when I graduated out of college, I was a developer. So I was actually working on Unix, programming in C, working on green screens. Very sexy stuff. And accidentally, I fell into the Windows world and became an infrastructure person. Literally accidentally. I went on some training about Visual Studio because we were going to port our product over to Windows. And then when our product got killed, it was like, okay, Aidan's a Windows guy now. That's how IT works. So, that's what happened. So I kind of understand a little bit the mindset of the developer, but I've spent nearly 30 years in the infrastructure world, and I have been the so-called bastard operator from hell. So some of you may have read that series of funny stories, the sysadmin who kills developers who get too uppity and stuff like that. I was that person. I reveled. I had fun making developers' lives misery. And then of course they turn around and go, can we get a restore of a database, please? And I'd be like, the database, what's the database's name? And then they tell me the name of the database, and I was like, okay, that's the first time we're hearing of that database. So I have been in this world. I've lived it as a sysadmin, and I've tried to work on it with customers as a consultant. And it is a challenge. And now we have the cloud come along. And when the cloud really started making waves, around 2007, 2008, this concept of self-service. And if you look at the National Institute of Science and Technology from the US, they define what a cloud is. And one of the 5 key traits is self-service. So it's not the concept of a developer needs somewhere to do stuff. They call up a help desk or they lodge a ticket and wait 3 weeks for something to be done. And they get what they didn't ask for. No, the idea is that they go into some portal, provision something themselves, and either a few seconds, few minutes, or an hour later, it's there. And they didn't have to go and open up a help desk ticket. And that's what has drawn business to the cloud, is the concept that we can go to the developers, the people who empower our business, the ones who help us make profits, the ones who help us run our operations. We can go to them and say, we have this problem, can you solve it? And then the developers and architects sit down and go, right, we do this. Okay, where does this stuff run? So the old days in the cloud, everything had public endpoints. And you go, we're next. Oh, I have an app service, I have an Azure SQL, I have an Elastic Scale database that is a public endpoint. Security, who even thinks about that? But we make the thing work, and it's really cool, and the business is really successful. Until one day, some bad guy just probes that IP address and realizes, that's using a default password, or there's no password. There's no network protections. I can just attack that thing. I can do a SQL injection attack in that application because there's nothing looking for a SQL injection attack. And now the business gets worried. In Europe, we have things like GDPR and NIS-v2, which are cracking down on security. And a lot of organizations, so anyone handling personally identifiable information or personal information, anyone who's involved in so-called critical services need to comply with either GDPR or NIS-v2, which means a lot of security. And it's very clear when you look at GDPR and NIS-v2 that the people who are responsible for security are the executives, not the IT staff. And not only can the organizations be fined, the executives can be fined, the executives can be imprisoned, and they can be banned from being directors of companies. So now they're starting to go, yeah, because if they're basically, performing professional negligence by not taking care of security, then they're going to be held accountable by the European Union and the local legislators. So security is now really important. So we have IT who have this traditional approach of where we're locking things down and we're taking control of everything. And you have the developers who are coming along and saying, no, we need agility. So how do we solve this? Well, the traditional solution is a cage fight to the death. And somebody wins, somebody loses. And I've been on both ends of that. I've been the winner, and the developers have been unhappy, and the business has been unhappy, and I've been the loser, where the IT department was made redundant. And so it's not a good solution for anybody. And in the end, the business loses. And when these two units who are supposed to be working together, the IT team who are providing the essential infrastructure, working with the security team, securing the assets of the business and securing the future of the business, and the developers who are trying to provide operations and profits for the business to actually exist. So it's a challenge.
And today, especially for small, in the latest year, especially for smallest companies, the role before they were really ITs and let's say developers, and today also developers became ITs. So you end up to manage infrastructure, as you said, like in a sort of building up infrastructure, and maybe sometimes not knowing all of this concept about network security, isolation and perimeters, and routing and things like this, and firewalling. Or I remember at that time, if you didn't have the DMZ, you couldn't expose any kind of workload. And today it's just like, okay, do we still have a concept of DMZ? Sometimes yes, sometimes no. But like developers or became also network infrastructure architects. So how do you see this? That it create a huge mess? So how do you see these things happening in the smaller companies?
So 6.5 years ago, I did a security audit for a company in Norway, and the network admin, really smart network admin, had built the Azure environment, and it was incredibly complex and locked down. And the developers, out of frustration, I could see that they had started to put databases in the network in front of the firewall, so naked to the internet, because it was the only way they could get their applications to work. Because the environment was A, so complex, and B, they had this single gateway they had to get through, which was the network admin. And who wins there? Nobody wins. It's a lose-lose situation for everybody involved. Yeah, so we need to come up with a better solution to this.
Yeah, and let me go on this. So here, when I look to sort of a map of networking that Stefan created here, it's really a huge picture. So firewall, L7, so routing things. The DNS is per se a cause of a huge headache. and like also on all of the peering and networking and things like this. So if I'm someone new to networking and I want to approach to networking for the first time, where do you think I should start?
The place you should start is the Cloud Adoption Framework from Microsoft. And if you're a complete newbie, the thing to start looking at is the concepts of landing zones. So Microsoft have given us two different things, which basically are the same thing, to be quite honest. You have enterprise scale, which is this concept of we can give you an environment in Azure that's governed, secured, provides networking, provides the flexibility to run networked and non-networked workloads, and enable the business to have governance, IT to have control, security to make sure everything is secure and compliant, and the developers have their own agility. And if you look at a recent terminology that we've seen from Microsoft, it's the concept of landing zones. And it's to reinforce something that Microsoft did push in Cloud Adoption Framework, but everyone seemed to go la 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 la, including Azure teams themselves, who needed some punching. And there's a team I could think of who needed a bit of a punching to realize things have changed in the last 5 years ago. Things have changed. So the landing zones, they even broke down the terminology of that, where they gave us the concept of platform landing zones that are run by IT, application landing zones that are run by the developers and operators. So the concept, from the networking perspective, is what we call hub and spoke. So this is our starting point in a networked infrastructure in Azure. So if we have workloads that need to be secured and follow compliance or regulatory compliance or whatever, we typically network them. Now there's something, and one of the things I try to get across to customers is try to classify your workloads. Does a workload need to be networked? Does it need to be deeply networked? Or can it be just, excuse me, or can it just run on public endpoints? And that should be a predetermined process to look at the workload, look at the data and say, right, this is where it fits. And we drop it into the right place in our infrastructure based on that. Excuse me. So we build this hub and spoke architecture. The hub is a platform landing zone. It's controlled by IT. It's controlled by security. It's where our site-to-site connectivity is. So our hybrid connectivity to on-prem and to remote physical locations and even to other clouds. We have a firewall, and that thing is sitting in the middle, and that's doing our isolation between the outside world and the inside world. But here's an important thing. We should be implementing zero trust network architecture, or zero trust to begin with. But if we're focusing on networking here, so we're doing a zero trust networking architecture. So not only are we isolating the outside and the inside from each other in both directions, because you want to stop the bad actor who's already in your network from communicating with their command and control systems or stealing data. So we want to control the egress flows. But we also want to control east-west traffic between our different application zones. So we don't want application A talking to application B if it doesn't need to. And if it does need to, we want to tightly control that communication. And that's done using that firewall in the hub. But in the application landing zone itself, the developer is going to have quite a bit of freedom to be able to do their own thing. Now, excuse me, bad morning for coffee. So in that application landing zone, we want to give the developer as much freedom as possible. But this is where IT will sometimes come in and go, no, there's a network in there. I am not letting you do stuff with that network. Or you're going to be deploying VMs that I don't approve of. I don't want you to have the rights to deploy VMs. Well, this is why we should be using another thing that's outside of networking. But it's still, if you look at it and start categorizing it by networking, you'll see it has a lot to do with networking. This is Azure Policy. So Azure Policy now allows us to put guardrails in place to say, right, developer, you can do stuff. Excuse me, but you can't do this stuff. I'm going to steer you to the good solutions. So for example, when you're in the Azure portal and you go next to deploy a virtual machine, I'm not going to let you deploy a public IP address on that virtual machine because that is a security violation. That is something that marketing and Microsoft decided was a good idea because it helped someone evaluating Azure to get a virtual machine up and running very, very quickly and be able to browse a website very quickly on that virtual machine. In the real world, is actually hell on earth. Excuse me. So that's really bad. We can use it to automate other things as well. So from a security perspective, we want to have visibility on network traffic. We want to be able to audit it. We want to be able to troubleshoot. We want to be able to do security investigations. We can use Azure Policy to implement virtual network flow logging. So we can automate that so the developer doesn't even have to know about that. And then there's other things. So I said we're going to build a hub and spoke. Does the developer, when they build a virtual network, know that they should be attaching this thing to a hub? Do they know how to configure the peering connection? Probably not. It's not something they want to even care about or know about. However, we can automate that. So Azure has given us a solution called Azure Virtual Network Manager. And Network Manager allows us to build a mechanism where we can search for virtual networks on the fly. And when we find them, we can deploy certain configurations to them. So the first most basic one of those is connectivity. So we can say, oh, all these virtual networks that meet these criteria are going to be connected to this hub. So now these virtual networks, these application landing zones, are going to be wired into the hub. That means now they can talk to on-prem if firewall rules permit it, and they can talk to each other if firewall rules permit it. So now we have an integrated and connected environment. Now we want to force that traffic to go through a firewall. Traditionally in Azure, that means doing user-defined routes in route tables. That's another thing the developer doesn't want to care about or know about. Again, we can go to Virtual Network Manager and say, we do this automatically.
That's very cool. And just like while you were talking, some question or maybe too many questions came up to pop up to my mind. And one of these questions is like, when there is in those hub and spoke, when you have all of this network functionality centralized in the hub, sometimes can be difficult to understand what is the ingress, what is the egress. Of course, everything is on the central place. So everything that is connected to that central place it can get access to those functionalities. So sometimes it can be unclear what type of traffic each spokes needs. So my question is, do you in the real world see a sort of multi-hub scenario where you have, I don't know, a hub for the ingress, and a hub for the egress, and a hub for the hybrid traffic, or just like one single hub and all the spokes then connected according to the categories you were mentioning?
Keep it simple, stupid. And the KISS principle. One hub. So I use the concept of a data center, and I use that in the cloud to kind of explain how things should be configured. Because we're familiar with the concept of a data center from the physical world. And in the data center, we have a network core. And that's the one place in that data center where things go in and out. And in Azure, that's our hub. So if I'm deploying a Azure region, let's say in West Europe, in Middenmeer in the Netherlands, I'll build a hub there. And any applications that I'm, or networked applications that I'm deploying in West Europe will peer with that hub in West Europe. Well, let's say I turn around and say, right, I'm actually going to put some applications into France Central. You know what? That's another data center. It needs another network core. So I'll build a hub there, and I'll deploy my application landing zones or my spokes in France Central, and I'll wire them up into the hub or peer them to the hub in France Central. And that's how I would scale out. And there's a certain amount of spokes that we can have. There are technical limitations on how big you can go. The simple answer is 400 application landing zones per hub. But if I want to, excuse me. Oh, excuse me. If I have more application landing zones that I want to put into France Central, I build another hub.
Okay.
It's another data center. So it's much like how the likes of Microsoft operate. They don't just when one data center fills, they build another data center in the same location.
Cool. And another thing that came up, you mentioned north-south and east-west traffic.
Yeah.
And when in these hubs, that's a question that I had sometimes ago. I say, okay, I'm looking at east-west traffic, and this east-west traffic goes through the firewall. And then the question was like, but I'm a little bit confused, Massimo. Is this firewall, what is the role of this firewall? Is this firewall a firewall, or it acts also as a router? So is violating the single, principle. So what's your take on this?
It's being both, just as it would be in an on-prem environment. Your routing will configure your subnets. Well, actually, subnets don't exist. It's configuring the NICs in the subnets to say your next hop when you leave the virtual network is to go to the firewall. And the firewall looks at the traffic and says, right, that's allowed. I will forward it to whatever the destination is. So yes, it is operating as a router. Excuse me. So it is the thing that's enabling transitive routing between the spokes in a hub and spoke environment. But it is a firewall. So its primary function is firewall. But to be a firewall, it must be routing. Just like it would in an on-prem environment.
Okay. And another things like that came while you were talking about the virtual network manager. This question about operation came to my mind. So suppose in these hub and spoke scenarios, so IT is managing all the platform landing zone, and then there is this application landing zone. So multiple applications will come up. So what do you provision automatically when there is a new application? And what do you do via virtual network manager? So do you create already, once you know the networking requirements like the size and things like this, you do these things like automation, or you just first create an empty landing zone and then you go with the virtual network manager to create the peering? So what is the way to operate and control these kind of things?
That will depend on the maturity of the organization. So the most basic thing you're going to provision for a new application is a subscription if you're following the cloud adoption framework. So yes, you could have hundreds of subscriptions. And quite honestly, that makes governance and security much simpler. Ask anyone who's ever gone into an environment, an environment that's new to them, like as a consultant, and they have a single production subscription, and there are hundreds of resource groups in there, and you can't find anything. It's an absolute nightmare. And it doesn't matter what the naming standard is, because you just can't find anything. Where I turn around and say, listen, you're going to have a single subscription for an application. Everything for that application is in that subscription. And they go, okay, that sounds weird. You'll have someone go, well, that's just going to be very complicated. And it's not. Going to the Azure portal, filter my view just to that one subscription. The only thing I'm seeing is the resource groups and the resources for that workload. So simpler to find things. If I'm asked to delete something, hell of a lot safer. Better for quota management. Easier to do role-based access control, because I do role-based access control primarily at the subscription level, not on multiple subscriptions for a workload. So if I just need to say, listen, Massimo, you're going to be going to have contributor rights on application X, I only have to do that on subscription level. I don't have to do that across 10 different resource groups.
We all been there on, especially I'm thinking around 10 years ago or so, where everything was in a single subscription. It was a hell, real hell. I feel what you're saying. It was just like impossible to manage, let's say, to keep it under control for a security point of view. For network, even worse.
Yeah, and cost management gets easier. Everything just gets easier in every sort of way. More mature organizations may have a concept of a subscription factory, where they actually provision a ready subscription for the developer. So they'll say, right, not only are you getting a subscription, but you know what, we're going to automatically configure Defender for Cloud. We're going to set up certain resource groups and certain resources in there. So we're going to pre-provision a budget that you just need to tweak. We're going to put in some basic monitoring stuff. And that stuff will just be sitting in the subscription. Oh, and we'll give you a network. Or we may not give you a network, we'll give you a place for a network. And then you go and say, right, I need a network. Okay, what address will I give that network? So that's where you go to the spreadsheet and you try to figure out what address space is available in the spreadsheet. No, Aidan, no. You mentioned Virtual Network Manager. Why can't we use the IP address management feature of that? Because the IT people have already set up an IP prefix for my data center in France Central. And I'm putting an application zone in there. And someone has said, right, this needs to be networked because there's personally identifiable information in there. Okay, I'll build a virtual network. I know from my application architecture how big it kind of needs to be. So when I'm in the Azure portal or I'm doing my base up or Terraform, I point at instead of me putting in the address space, I point at the resource ID of the IP address management pool.
Interesting.
And tell it how big I want it, and it automatically provisions the addresses for me.
Great stuff.
How sweet is that?
Yeah, it's awesome. It's awesome how it evolved the practice around managing networking and the properly design the network that scale and is secure in how it evolved in the latest years. We're almost out of time, so I have one last question for you. It's just like again, it's about monitoring and troubleshooting. Which is the same question from application point of view, with all of this abstraction in the cloud, all of those virtual components. What is your opinion about the level of monitoring or observability that you have for from a networking point of view? Are you satisfied with the network flow and all of the tools that you have, or you feel that you're still missing something, or is too scattered over the places? So what's your opinion?
That's a complicated answer. So in terms of how the networking works, I'm very happy. The biggest thing that most people do not understand is the packet always goes directly from source to destination. Your virtual network doesn't exist, the subnet doesn't exist, the default gateway doesn't exist, peering doesn't exist. The packet always goes from source to destination. Virtual network and peering are just instructions to the fabric to say, hey, there are now more NICs that my source NIC can send packets to. That's it. That's all these things do. So there is no virtual cable. There's no operator getting on a tricycle in a data center every time you peer with a very long patch lead to run it between two switches. That stuff doesn't exist. It doesn't happen. So when you understand that the networking is extremely simple, and the function of routing is actually to say, instead of sending a packet to that NIC, I want you to send it to this NIC, which will then forward it to that NIC. That's what routing it does. So when you understand that, the networking works perfectly well from my perspective. What could be better is the monitoring. If you're working just with virtual machines, which I'm guessing you as a developer, you rarely try to do, then the tools are great. Network Watcher gives you a whole bunch of stuff. Connection Monitor itself is awesome. You deploy a Network Watcher agent on your source and destination machines, including on-prem via Azure Arc with the Azure Monitor agent. And you can configure a test group, and the cost of the thing is almost next to nothing. And it will fire packets according to your instructions. So you tell it, hey, run a test every X minutes, and I want you to test this protocol and this port. And if it gets there, that's good. If it doesn't get there, let me know. So trigger an action group. Or if it takes too long to get there, trigger an action group. So we can measure the success, but we can also measure the latency. So that's all good. We've got virtual network flow logging, so we can see the packets passing through virtual networks. And we get a lot of information about that. Did it come from peering? Did it come from a global source, etc.? Azure Firewall gives us logging as well, so we have a lot of detailed information in there if you're using Azure Firewall in your hub instead of one of the third parties. So tons of information actually there, so you can track the packets. Where things get a little more difficult is when you start saying, hey, I want to use an app service environment, or I want to use SQL Managed Instance, or I'm going to use an Azure SQL One private endpoint. Troubleshooting that stuff gets a bit more difficult because you don't have the likes of connection troubleshooting stuff. And the challenge is that these things don't even live in your tenant. They're running in a Microsoft tenant, and they surface themselves in your tenant. Troubleshooting routing is very difficult with third-party, with platform services, especially those ones that have a dedicated subnet. So SQL managed instance is a perfect example, or the virtual network gateway. I can't come along and inspect the effective routes on the NIC like I can with a virtual machine. So I don't know what the actual next hop is, and the tools don't deal with those PaaS resources either. So when I go into Network Watcher and say next hop, it's expecting me to select a virtual machine. And if I want to see, our packets allowed in my network security group, again, Network Watcher expects me to point at a virtual machine. So from that perspective, it's challenging. And I don't think there's even going to be a way for a third-party tool to be able to fix that, because they can't put an extension or an agent onto SQL Managed Instance, because this, again, is something running in a Microsoft tenant, in a VM or a container that's managed by Microsoft.
It's getting a gist out of there. It sounds like a little bit of black magic, like at the end of the day.
The answer is understand how packets get from A to B, and understand routing, and then use the logs. The most important tool is the VNet Flow Logs. So there is an Azure policy in there to automatically configure VNet Flow logging. I would advise people, if they're worried about network troubleshooting, use VNet Flow logging, because that will show you when a packet is passing through a virtual network. It's going to show you whether it gets from A to B. So you can see as the packets are moving through your network where they're actually failing or where they're not appearing. And then that starts giving you a clue. So it's kind of like being, I don't know if you ever saw the show House, about that doctor.
Mm-hmm.
He used to investigate all these weird illnesses. And it's like, right, they've got this weird temperature thing that's killing their brain. Oh yeah, it's this, and this, and it's caused by a fungus in their toe. And it sometimes can be a bit like that. And of course, there's the old rule, which is it's always DNS. Never forget that. Relevant in the cloud too.
Talk for hours around this topic, because again, it's a huge area, networking and infrastructure, and also in their. It's not so. I mean, I found it extremely complex because I'm coming from the application point of view. So, but we can close the episode of today to say that let me recap or with one thing, if I got it properly, that one or your top advice would be like to set up VNet Flow Logs with Azure Policy. That's one of the things that people should always do. Did I get it right?
Yeah, if you're in that self-service environment, absolutely. Or there's consultants coming in, building virtual networks or whatever, managed service providers. Make sure you automate as much as possible. So things like Azure Policy, things like Virtual Network Manager, they will help you guardrail the environment so you get the balance between the control and the security and the self-service.
That's great. Okay, we are at the end of episode. Thank you so much, Aidan, for today to help us navigate the Azure infrastructure and networking landscape. And that's everything for today. So thank you everyone for watching, and see you at the next episode.
Bye.
Bye. Cheers.